I'm Ryan Batchelder, and I am here to talk to you all today about charting a course toward more resilient architectures in AWS, starting with the resilience of getting our laptop set up just in time here. Um, as y'all can probably tell from my funny American accent, I am from the United States. I'm from Boston. I'm a technology architect at Liberty Mutual, as Garth introduced. I've got over 8 years of experience breaking things in AWS and then figuring out how to fix them afterward. When I'm not sitting in front of a computer, I love to travel. Big ice hockey fan, which I know is not as big of a thing here, but you all have the Belfast Giants around. And I am very much an unapologetic aviation geek. So those who know me absolutely know that's true about myself. But that's not why we're here. So I like to start this talk with this question of like, why should we even care? And I do this for two reasons. One is y'all probably want to know what we're going to talk about here today. So I'll give the quick high-level rundown. We're going to start with some of the sort of basic concepts of resilience in AWS, and then we'll go into some practices that you can use for pretty much any application, no matter sort of where you are in the resilience journey, to improve your applications. But the second piece of this is, for some of us, one of the things that we were told when we migrated to the cloud or when we learned AWS or moved to a public cloud provider is that the public cloud can provide better resilience for our workloads. And that was just one of the flashy buzzwords among all the other ones, right? And if you just walked away and said, yeah, great, I'm in the cloud, surely my workload's resilient, I don't have to worry about it anymore. That's not quite true. I've got a collection of headlines here from a couple of big name vendors I'm sure you all have heard of, Google, Microsoft, that these are a collection of real incidents that happened to cloud data centers in the last couple of years. So Google Cloud had one that I know a couple of my colleagues poked some fun at last year, the year before, where they had a zone in Paris flood, and the only response they had to customers was, I hope you can move somewhere else. And I think the OVH Cloud one probably gets a little bit closer here, where they had an entire data center that completely burned down, and the customers just had to invoke their recovery plan, assuming they had one. I don't know. So I think we can kind of sum up a lot of this stuff with a quote from Dr. Werner Vogels that everything fails all the time. Now, what this is getting at is kind of a point about as we continue to build more and more distributed systems, which is by nature what you're doing is you build systems in the cloud, we are starting to rely more and more pieces of infrastructure than we ever have before. And many of them you don't even know or think about or touch. Take some of the most basic components in AWS. You deploy an EC2 instance. And for what you do, you have that one instance of compute and maybe a couple of security groups and things around it. But if you think about behind the scenes, there's a whole host of different networking components that AWS is managing for you. They're also, of course, managing all of the physical infrastructure where that compute is living. And for the most part, the benefit of public cloud is we don't need to think about it, except we kind of do need to think about it just enough so that we're prepared for what happens, for what we would do when something happens to it. So, of course, Dr. Vogels here is not trying to speak negatively about his company. That'd be a little awkward if he was. He's not trying to say that AWS components are going to fail all the time. But AWS leaves us with this shared responsibility model for resilience. Now, if you've worked in AWS long enough, you've probably seen the shared responsibility model in one form or another. Typically, the one for security is the one that most folks know about. But the shared responsibility model for resilience is very similar to that one, which basically states that us as the customer are responsible for the resilience of our workloads in the cloud, while AWS as the provider is responsible for the resilience of the cloud itself. So you may look at this and think, surely if the data center burns down, AWS is responsible for it. And they are. They're going to be the ones that have to foot the bill to rebuild it. If a hard drive fails somewhere, they're the ones that have folks in the data center that go and replace it. But despite all of that, some of these incidents, as we showed with some of those headlines before, could impact your workloads. You need to be ready to handle those should something arise. And The way that we can work with that is through this mechanism called fault isolation boundaries. So we talk a lot when designing cloud systems about this thing called blast radius. And if you don't know what blast radius is, it's this notion that if a particular component fails, the blast radius is all the other components in the system that might be impacted by that failure. So if I've got an API server and that goes down, what are all the other dependencies in my system that can no longer call that API? Customers are not impacted by that, and that's sort of the blast radius covered by fault isolation boundaries are a mechanism to constrain that further. Now, of course, there are things you can do in software to do that. We're just talking about compute infrastructure and things that you do in the cloud. And AWS actually provides a number of fault isolation boundaries here. Some of these are going to be things that you maybe knew, yeah, obviously, and some of them you may not have thought are fit into that category. But we're going to focus primarily on regions and availability zones today. But accounts are another isolation boundary. Partitions, this is one that some folks, I know it was new to me. We typically don't see it that often, but the partitions are, there's the general customer partition where most of us live. There's GovCloud, which is set aside for certain government agencies that use AWS. And then there's AWS China, which has its entire own separate partition. Edge locations are, they're typically used for more specific like latency and other purposes, but they are technically a fault isolation boundary. And then of course, the last one here is not a physical thing, but it's actually how AWS is designed with the separation of control plane and data plane, which we'll touch on a little bit later on, but that topic could spend hours talking about itself. So, as I said, we're going to start with regions here. And I've got a map up here of all the regions that AWS has around the globe today. The green dots being ones that are available and publicly out there. Of course, we have the other partitions covered here as well. The red ones are ones that are not yet available but have been announced. And I don't know about you all, but my first exposure to regions is that little drop down in the top right of the console where you click up there and you've got to make sure you're using the right one or you can't find your workload. And I've lost many hours trying to find things that only to find I was in the wrong region. And I kind of saw that, and my initial thought was, oh, sure, I pick a region to put my workloads near my customers, and then they'll get better latency. Or I have legal reasons where I need to put certain components in certain places. Of course, very common here in Europe. But turns out that regions are first and foremost a fault isolation boundary, and they are both for us as customers and for AWS. So regions are a cluster of data centers, which are known as availability zones. We'll cover those in a minute. And they're in geographically distinct areas separated by at least hundreds of miles. So these are design constraints AWS uses when rolling out regions. And they're separated by at least hundreds of miles such that natural disaster that might impact one region should not impact another one. Each region has isolated control planes so that they should be able to continue to operate even if another region is experiencing an issue. So if we've got an outage in EU West 1, for example, EU Central should not have any impact from that, which is good because you want to be able to move your workloads between those regions. And as we saw on the map, there are 33 regions spread across the globe, and AWS is continually adding new ones. I've had to update that slide numerous times as I've given iterations of this talk. So next we have availability zones, or I'll probably refer to them as AZs a bunch today. And these are separate data centers within a region, each with their own separate redundant power supply. So these are, whenever possible, power grids so that power problems should not impact more than one availability zone. And these, in contrast to regions, are separated by just tens of miles, and they're interconnected by redundant fiber connections so that you can transfer data between them very quickly. For a lot of workloads, running between multiple availability zones in the same region should be effectively no different from a latency and performance perspective as if we were in the same availability zone. And we can actually look at examples of some of the bigger regions like US East 1 for evidence of this, where US East 1, AWS doesn't reveal all the details, but we know is made up of over 100 different buildings. And there are not 100 different availability zones in US East 1, so it stands to reason that availability zones will span multiple buildings at times. So you can't even guarantee that within the same availability zone, you're going to have workloads all right next to each other. There are mechanisms if you really need that, but that's not what we're here to talk about today. When you're deploying services that you want to use different availability zones, you won't always get the option that says availability zones in front of you. So what you might have instead are subnet configurations. Subnets will not span multiple availability zones, so you're implicitly selecting which availability zones you want to use by selecting subnets. RDS is a common one, you pick subnet groups and things like that. Lambda is running in a VPC would be another instance. And then this one is about like 50% trivia, but also 50% really important for the times where you need to know it. Availability zone names, so USC's 1A, 1B, etc., are not deterministic across accounts. This is important to know because if you are investigating some sort of increased latency or outage in one of your workloads in one availability zone, you say, okay, in EU West 1A, I'm seeing this problem, but my other workload over here is not having that problem. If they're in different accounts, that could actually be a completely different building, different availability zones. So you can't say you can't gossip about the failure across accounts. There are identifiers you can use, but they're not obvious. So just keep that in mind. You need to go that extra layer down. Okay, great. I've talked about like these two components. They sound really good, and let's just use everything. I want to do multi-AZ, multi-region for everything I've got out there. And I've had a lot of people actually say that they're like, thanks, great. I'm glad we've learned about that. And I don't need to go any further. I'm just going to do it. But there's this additional layer of nuance of recovery objectives. It's easy to say, yeah, I just want my workload to be the most resilient ever. There's the scene in the social network where they say Facebook should never, ever go down. We're always available. But not everything we build needs to be like that. I mean, if I have an API that serves up cat memes, I probably don't need that to be up all the time. So cloud resilience is a spectrum. And this is an important concept that is sometimes a difficult sticking point, especially between folks who are building the software and the business folks who are using the software, is that they typically want it up all the time. However, the further we go towards higher availability, the more expensive our workloads become. And that is not just in the infrastructure costs, which might be easy to think about, but the complexity in building a full active multi-region, highly available system. The amount of time that it would take to develop and build every new feature in a system like that is going to be much higher than my cat means API that I could probably run in much less resilient. So this is an important conversation to make sure you have with your stakeholders before we go any further. Make sure there's a mutual understanding in what the additional cost is going to be and what the actual needs need to be. An outage will happen to everybody at some point in your career. The important thing is how long can that outage be? And are you within the bounds of what is agreed upon to be acceptable for that? So before we go into the patterns, I just want to talk about sort of a quick comparison of multi-AZ versus multi-region implementation. So this is systems that are running within a single region, but you're using multiple availability zones versus using many different regions at once. Because these are the two boundaries we talked about, and these are kind of the two mechanisms that you'll be thinking about moving forward. These are the big ones. Since I mentioned that AZs are very close together, building a multi-AZ solution doesn't typically come with too many latency concerns. Those should be generally, you should be okay from a latency perspective, moving from let's say a single AZ, single instance to a multi-AZ build. Multi-region, of course, changes the math on that quite a bit because, as I said before, regions are geographically quite far apart. And especially if you're looking at workloads that span oceans. So if you're looking to have a failover region in the US where your primary is in Europe or some combination, that latency becomes a greater and greater concern. AZ failure, just by nature, it's the smaller component. That failure is generally more likely than an entire region. Because if you take an entire region, there's a lot of different things that have to go wrong before that fails. So being prepared for the more likely scenario makes sense to invest there. Of course, regional failures tend to be much more rare. However, they are much more impactful. For a long time, US East 1 was kind of known as the region that fails the most. And when it fails, it kind of is a internet is entirely down sort of event. Um, AZ failures happen a lot, and most of the time we're probably not even aware of them happening because they don't cause that level of an outage. Most services, especially managed services, serverless components, things like that, make multi-AZ actually really easy and often pretty cheap. So a lot of times going with moving from single AZ to multi-AZ can be as easy as checking a box and maybe paying a nominal additional infrastructure fee and having almost no additional complexity in your actual system. Multi-region is quite a bit more complicated. There are a few services that provide regional failover, but even then, there are certain aspects to that where they're not seamless. They do require a little bit of manual touch, and they do generally come with a bit more logistics concern. All right, and the last thing is backups. This is an interesting topic because I have had people come to me and say, it's okay, Ryan, we don't need to worry about backups. S3 has like a bazillion nines of durability, and I promise we'll never lose data in S3. And like they're not wrong. However, uh, durability numbers serve the AWS side of the shared responsibility model. They stand to say that AWS can lose a whole lot of hard drives before you're going to lose a file. They do nothing for the scenario where oops, I accidentally hit the delete button on the wrong file in production, or ran that SQL query without the where clause, or some it could be even a user who deleted a file by accident that's critical. No amount of durability or synchronized replication or anything like that will save you from those. The second that delete happens, all those synchronized replicas are deleted as well. So it's really important, and I come from, of course, insurance world where data is everything. I would wager that many of you are working in some industry where data is super critical, if not the most critical component of your business. So no matter what you do, if you take nothing away from this today, make sure you go back and think about how your data is backed up, because this is something that I know, speaking from our perspective, a lot of folks figured in the data centers, we had folks that ran in those on-prem worlds that handled backups and things like that. Most of the software engineers that we worked with didn't have to think about it. That didn't translate perfectly to the cloud. So this is a case where you do need to be thinking about that and making sure you know what would happen to that data if something were to happen to your resources. And then the last piece to this is that backups should be a immutable snapshot of that data. You should be able to walk back to that point in time. And the immutability is important because if your backup is a cron job that just copies files to another folder somewhere on your disk, and then that oops that you did erases everything with a star or something along those lines, then you may not have backed up in an effective manner because you still won't be able to. All right, so now that we've got all that out of the way, let's actually plan our resilience journey. So we're going to go through these steps here. We're going to start with our backups. As I mentioned, those are super critical. We're going to identify our potential failure points, implement mitigations, and then we're going to plan for disaster. But before all of that, I'm sure I don't need to tell anybody in this room, I'm sure everybody's got up-to-date architecture diagrams all the time. Every time you make a change, you update that diagram. But just in case you're anything like me, make sure you start with an updated diagram because you may not have one. As with everything in life, preparation is key. So the rest of these steps here, we're really going to be looking at a diagram that looks sort of like this one on the screen here, probably with a little bit more detail, but you want to focus on your infrastructure components as they stand. Of course, this is an AWS community day, so we're going to focus on AWS components, but you could mix in if you've got a multi-cloud or a hybrid application and mix those pieces. So step one, start with backups. What I like to say for these first couple of steps is take that diagram we just put together and walk it from beginning to end and choose whatever makes sense for your application. This could be walking the workflow of a user request. This could be choosing different types of workflows that somebody might go through, like update profile picture, and walking those piece by piece. Whatever makes sense for your application. The important thing is you're going to take that diagram and stop at every component you have along the way. When you land on one that has data stored in it, database, S3 bucket, file system, whatever it is, ask yourself, what would I do if that disappeared tomorrow? Now, the answer might be, well, I'll do nothing because it's a cache or it's reports I can regenerate or something like that. Fine, great. Save yourself some money. But if the answer to that question is our business would be completely toast and people would be yelling and I would be in a lot of trouble, then make sure it's something that you're backing up and you are accounting for unintentional deletion or modification in your backups as well. Because again, the problem that might cause you to go recover from that backup may not be caused by AWS, may not be caused by you or another person on your team. It might be caused by the user at the end of the day. And we want to be able to help satisfy those requests if they say I made a mistake and I need some help. Number two is to identify your failure points. So you want to be asking yourself at every piece of the infrastructure, what could go wrong here? And if something went wrong here, what would happen to my application? There's going to be a different answer for every component. Some of them may say, this is going to cause a complete outage and people aren't going to be able to do anything, and that's probably not good. Maybe somebody can't update their profile picture, their avatar, and maybe that's not as critical. And you want to make sure that you are scaling your recovery plans accordingly. And of course, determine if there are opportunities for redundancy. I don't think in this case it would have made sense to have a second pre-mark for redundancy, but we did. But I know that this one is now open again. Last time it was in Belfast, it was in this stage. And step three is now to implement. So take everything you just went through in step two. Once you've kind of walked your entire system and you've kind of got a list going, whether Jira tickets, a scratch pad, whatever you've got, and you've got all this stuff on your to-do list, now it's time to actually go and implement that stuff. Get those redundancies in place. And remember that managed services are often redundant across availability zones out of the box, like I said. So in some of the cases, the answer to, what do I need to do on a failure is nothing. The best recovery that you have in any of these is to have to do nothing. If you don't have to wake up at 3 a.m, you don't get paged, there's nobody running around with their hair on fire, that's the best case. And whenever possible, that's what you want to be striving for, as long as, again, it makes sense from a financial standpoint to your business partners. Now, this is my favorite step, is to make a plan and test. So when I had asked this question to a room in the US, I got a shocking response. So by a show of hands, who in this room knows how to use a fire extinguisher? I'm glad that is far more people than I got in the US. The important thing here is you do not want to be learning how to use a fire extinguisher while there's a fire burning in front of you. Ideally, you should know how to use it beforehand. And that applies to your disaster recovery plan as well. Whatever your plan is, whether it's I've got to restore everything from scratch, I've got to redeploy cloud formation templates, I've got to SSH into an instance and do something, or your plan is I have a nice script I can just hit run. No matter what, you want to make sure you have practiced it and that other people on your team who might be involved in that recovery have practiced it as well, as many times as possible before an incident actually happens. All of your backup and recovery plans are only as good as when they were last tested. Things change in cloud environments all the time. Now, if you're on your own in a personal account, or you might have a small company, things might not change as quickly as in other scenarios, but you never know when AWS is going to change an API. If you're on a bigger company, new governance rules might be rolled out, new enforcements. Your laptop might have got updated and that shell script you have doesn't work correctly anymore. There's any number of things that could go wrong. You don't want to assume that, I haven't made any changes to the system, therefore everything's going to be working the same as it was before. Remember, we're in a big public cloud shared environment where things are going to happen to us. So you want to make sure you're testing these plans as often as you can. I know that we have teams that often test in lower environments, and I get it. Taking down production for the purpose of a test is kind of scary, and that's okay. But this time more than ever is the time where it's most important to make sure your production environment matches your your lower environment to match your production environment identically. Same exact instance types, same counts, all that stuff. I know a lot of times we say, sure, but in dev, I don't need the M5 4x large or whatever instance. But during a disaster recovery, you need to make sure they're the same because there are limits in place. There are scaling restrictions that you may run into in your lower environment, or you may run into during an actual recovery, which would be a thing you didn't anticipate because you didn't test it in your lower environment. So make sure you have that identical environment just for the duration of the test. You can go back to your lower scale, your nightly shutdown, whatever you've got in dev afterward. But you want to make sure that you've documented any potential pitfalls or gotchas so that whether it's you or somebody else in your team at 3 in the morning when you've just been woken up from sleep and you're kind of not sure where you are at the moment, you want to make sure you can follow those steps and they should be easy and able to be understood. Unless you're like great at 3 in the morning, in which case replace that time with whenever you sleep. So I hope you'll be able to hand these slides out afterwards. If not, you can basically Google anything I have here. I don't unfortunately have QR codes for these, but if you're looking to learn more, whether you are sort of early in the resilience journey or you have been doing this for a long time and everything I said here was kind of redundant to you, this first one here is an AWS white paper titled Fault Isolation Boundaries. If you are just starting out, this is going to have a huge wealth of information. If you are kind of experienced, this will probably have things that will scare you about whatever you think you know. So I highly recommend reading it. Of course, I have to give a shout out to the reliability pillar in the well-architected framework. It covers all of this and more. And then if you are more the video type of learner, this was a great talk in a reInvent last year. Our ARC 313, a consistent approach to resilience analysis for critical workloads. They go through a whole huge breadth of things. It's just a taste of everything that they kind of cover, but it gives you jumping off points to learn more. That's been me. Thank you, everybody. You can find me on basically all socials at RDBatch02. I will also be around one of the folks in the orange shirts here. So I don't think we have time for questions, but feel free to grab me anywhere in the halls or in the cloud room. Thanks, everybody.